Hello, in this video we will talk about power analysis and show examples of using power analysis for t-tests in RStudio. So what is power analysis? Power analysis is connected with the hypothesis testing, as which get some samples and to test if the null hypothesis will be rejected or not. And against the null hypothesis, for example, which shows the two samples have the same mean, and there is an alternative hypothesis which will reject this null hypothesis and say and favor that the two populations have different means. And in the power analysis, it allows you to determine the sample size required to detect such an effect of a given size and with a given degrees of confidence. So, and conversely, it also allows you to determine the probability of detecting such an effect of a given size with a given level of confidence in the sample size. So what this means, if we look at this figure, there are four elements in power analysis. The first, effect size. So what is effect size? Effect size is problem specific. So in a t-test, it is usually calculated with the difference between two samples and divided by standard deviation of the population. And for chi-square test, if we want to do the power analysis, it's different for effect size formulation. So sample size is correct. It's very simple, right? From the group in the t-test, for example, two samples, their sample size for n for each sample. And a significance level. So significance level is also called type 1 error. So this is the probability, usually very low, 0.05, for example. So this probability means if there is no difference in the, for example, in the two population, but we reject it, so we make an error, and this error is called type 1 error. And usually we want to set this type 1 error very low, 0.05 or 0.01 practically. And the fourth element is called power. So power is also called 1 minus type 2 error. So what is type 2 error? Type 2 error is against type 1 error. So type 2 error is actually it exists an effect. So actually the two populations are not the same, but we did not reject this null hypothesis. So this is a type 2 error. And 1 minus type 2 error is called power. So power is actually the probability that we reject and null hypothesis, and actually it should be rejected. So this is the power of the test. So we usually hope this power as large as possible, right? So these four quantities, sample size, significance level, power, and effect size, if we know three of these four, we can determine the fourth. We can get the fourth. So these four elements are connected, right? So in R, if we want to do the power analysis, we can use the power package. And under this power package, there are various functions. For example, this is for the t-test. So t-test is to test if the two populations are the same from the given sample. And in this function, power.t.test, there will be specified with the elements we talked in the previous page. So n is the sample size. This is for each group. There are two groups. So this is for each group. And d, effect size. And this is defined as the standardized mean difference. So usually if we want to detect, for example, difference 0.1 is and effect we want to detect. Divided by the standard deviation of population, we'll get the effect size. Significance level here and the power here. An alternative is for one-tailed test or two-tailed tests. Like this. Also another is called type. Type is for the two sample or one sample. Usually there we use two sample here. So next we will show an example. This example focuses on cell phone use reaction time and cell phone not use in the reaction time for the driving. So two groups, both driving, but one use cell phone and one did not use cell phone. And we observe these reaction times and get the mean reaction times for these two groups, and we'll test if the population of the reaction time for these two groups, two populations are the same, right? And the question one is, if you assume that you know from past experience that the reaction time has a standard deviation of 1.25 seconds. Also, suppose that 1 second difference in reaction time is considered an important difference. So here means this 1 divided by the 1.25 is an effect size, right? And you would therefore like to conduct a study in which you are able to detect an effect size here or larger. So you want to detect such an effect size from the sample. And additionally, you want to be 90% sure to detect such a difference if it exists, and 95% sure that you won't declare a difference to be significant when it is actually due to random variability. What these two sentences mean? So this 90% is the power. So power is actually it exists this effect and you can detect. So this is the power of the test. And the 95% here is the significance, is the 1 minus significance level. So significance is 0.05 here. Because 95% you won't declare difference, you won't reject, and actually it is due to random variability. So actually it does not exist such an effect and you won't declare. This is also correct, right? So 1 minus this correct probability is the type 1 error. Type 1 error is actually you reject this null hypothesis, and actually it is true. It is just because of random variability. So actually it has no such effect, but you reject it. So this is 0.5% for the significance level. So the question for the first question in our problem is how many participants will need in your study. So this is the sample size you want to require, right? You require to detect such an effect size and earn this significance level and under this power level. So next we will show in RStudio how to implement such kind of power analysis. So first we have to load this package called PWR, and usually you have to install this package manually first. So load this package, and next we use pwr.ttests, then D is 0.8 because 1 divided by standard deviation is 0.8 here. So significance level 0.05 and power 0.9. The type is true sample and alternative is two-sided. We just run this and we'll show the results. Here N is 34. So this 34 is for the one group. So actually you need 48 total in sample, right? So this is for the first question. Then second question is, now we alter the question, assume that in comparing the two conditions, you want to be able to detect a 0.5 standard deviation difference in population means. So here, effect size is 0.5, and you want to limit the chance of falsely declaring the population means to be different to 1 out of 100. So this is falsely declaring the population to be different, which means this is the type 1 error, right? Because we falsely detected this effect. Actually, it is not exist, right? So here the type 1 error is 1%. And additionally, you can only afford to include 40 participants in the study. So this 40 is for the total sample size. So which means each group has 20, right? So the question is, what's the probability that you will be able to detect a difference this large between the two population means given these constraints? So this is the power. So question is, what is the power of this power analysis? Because we know the effect size, and we know the significance level, and we know the sample size. So we know all these three, and then we'll get the force for the power. And same as before, we can just use one line of code to solve this question. So power.t-test, and here we use n is 20, and the effect size is 0.5. Then significance level is 0.01. Type alternative same as before. Just run. So now power is 0.14. It's quite low. So which means 1 minus type 2 error is 0.14. So which means you have 86% of the chance, 86 probability of the chance that you will not reject this null hypothesis, and actually it exists, right? So this is quite low power, because you have only 14% to detect such kind of effect. Actually it exists, and other 86% of the probability you cannot find this effect. Actually it exists, right? So from this second problem, we can also confirm that the first problem needed 68 at minimum sample size, right? Because here is 40 is much less than this minimum sample size to detect the power, detect the effect, right? And if you are not familiar with the hypothesis testing, you can review in statistic books of hypothesis testing, because power analysis is quite closely related to hypothesis testing. We hope this video will give you some elements on this topic. Thanks for watching.